Good day, I am Jeremiah Doliente, an MS Energy Engineering student. I will present the evaluation of indicators to identify the requirements in implementation of solar cells in Region 4B of the Philippines. MIMAROPA are a group of islands in southwestern part of Luzon group of islands. The acronym of MIMAROPA is combination of its constituent provinces, Mindoro, Marinduque, Romblon, and Palawan. The objectives of the study I have done for solar cell feasibility in MIMAROPA region are identify the suitable places in the region where solar thermal plants can be built, evaluate the amount of electricity from solar cell that can supply the demand in electricity in the region, and evaluate the best type of solar cell that can be used in building solar farms in the region. About one-fifth of MIMAROPA land area is an agricultural land area, while the rest of the region is forest, mountain ranges, and coastal areas. The western part of Palawan, together with Mindoro Occidental, experiences the Type 1 climate. The eastern part of Palawan, together with Romblon, experiences the Type 3 climate. The Marinduque and Mindoro Oriental has the Type 4 climate. Shown in the table are cities and municipalities in MIMAROPA with high population density. Puerto Princesa, Palawan has the highest population. The big industries in the region are services sector. Public administration, defense, transportation, storage, and communication are sub-industries of services sector. Other industries are trade and repair of motor vehicles, motorcycles, personal and household goods, financial intermediation, real estate and renting, tourism, and agriculture, hunting, forestry, and fishing. The products of micro, small, and medium enterprises in the region are agricultural and food products. The location of MIMAROPA region is 9.8432 degrees north latitude, 118.7365 degrees east longitude. With these coordinates, the parameters shown are used to calculate solar irradiance in the region. Solar irradiance per day is calculated using azimuth angle of sun and solar zenith angle. The emitted energy flux density or irradiance is the solar power density in Earth's surface, which has value 1,353 watts per square meter. Shown is the formula for calculation of solar irradiance. Shown in the graph is the solar radiation per day in a year in MIMAROPA region that varies according to varying declination angle of sun. The total solar irradiance during wet season is 141,242.01 watts per square meter, while for dry season, the solar irradiance is 189,887.79 watts per square meter. The primary sources of electricity in the region are diesel and coal. The other renewable energy resources of electricity are wind turbines, solar, biomass, and hydroelectric. The indicators to consider in installation of solar cell in a region in Earth are topography of the region, which includes flood susceptibility, rain-induced landslide susceptibility, distribution of active faults and trenches, and earthquake-triggered landslide susceptibility. Geographic coordinates of the region to determine the solar irradiation, areas with high dense population, economics, climate in the region, and the standards and laws in implementation of solar cells. Installation of solar cell in MIMAROPA is feasible. Solar cells can be installed in residential houses made of concrete and metal roof, buildings, and in agricultural lands near the highly dense population cities and municipalities. But the susceptibility in flood, landslide, active faults, and earthquakes of a specific place in MIMAROPA must be considered. Because power conversion efficiency and external quantum efficiency parameters limit the performance of solar cell, it is recommended to build a hybrid solar power plant with other renewable energy. Shown in the table is a demand forecast per island in MIMAROPA region for 2016 to 2022. Assuming for 1 year, there is 10 megawatts demand in electricity for an island or grid. The solar peak hours is around 4.5 to 5 hours. The recommended power capacity of pure solar thermal plant for each island or grid in MIMAROPA region could be around 18 megawatts. Shown in the table are properties of materials used in solar cell. Shown is the plot of absorption coefficient and wavelength of some materials used in solar cell. The best type of solar cell that can be installed in MIMAROPA region is homojunction polycrystalline silicon or amorphous hydrogenated silicon solar cell because it is cheaper than monocrystalline silicon solar cell and has superior characteristics such as high efficiency, good thermal stability, and high absorption coefficient for wavelengths near ultraviolet rays. One of the places in MIMAROPA region to implement solar power plant or hybrid solar power plant or install solar panel for a residential house is in Puerto Princesa City, Palawan. In this area, there is low flood susceptibility, rain-induced landslide susceptibility, distribution of active faults and trenches, and earthquake-triggered landslide susceptibility. The island of Palawan is far from earthquake fault line. Puerto Princesa City is also highly urbanized and has the highest population in the region, translating to high GDP and good economy. Shown in the figure is the possible location to build a solar power plant near Puerto Princesa City. Solar panel can also be installed in residential and industrial building to provide electricity in the city. The tilt angle of the solar cell depends on the changing declination angle of sun per day and on the design engineer who will install the solar panel for power plant, residential house, and industrial building. It is recommended that the tilt angle of solar cell is changing and has plants surrounding it to stabilize temperature and maintain power conversion efficiency.